Hello and welcome to another Ziva VFX tutorial. In this video we're going to be looking at making a muscle fiber. So as you probably know, muscles in the real world are packed with fibers, and the fibers contract and allow you to do things like lift stuff and walk and chew, that sort of thing. And we can model that within Ziva. So if I select a tissue object and then under the Ziva menu come down to add simulation property and this time select muscle fiber. I'll just switch to default shading so you can see it more clearly. But Ziva tries to guess the orientation of your muscle object. It usually does a pretty good job. And you can see that we got this fiber field here. And this represents the direction that the fiber is going to contract the tissue. And this is all fully editable after creation. So if I go onto the solver node, and then I'm just going to hide all attachments. Change that to none. So you can see in this part of the muscle, it's kind of got a nice fiber flow, but it gets a bit confused up here. The reason is that there's a map on the fiber that controls the direction of the fiber field. So it's really easy to edit that. So if I just isolate this for now, and then I'm just going to come down to Z fiber, and then I'm going to choose endpoints. And you can see that Ziva's already painted one vertex perfectly white, and at the other end it's painted to black, and everything else is 0.5. So Ziva uses those values to work out how to construct the fiber field. So you can have more than one vertex painted a certain color. So what I'm going to do is paint this vertex to be white as well. I'll use that mode. Alright, just those ones there. And now you can see that the flow has changed to be a bit nicer. So go back to 0.5 and I can do that sort of thing. And it doesn't matter too much up at this end of the muscle. You want the fiber field to be correct in most of it. You can also paint, just while we're here, you can also paint the weights of it. So just quickly, at the moment it's going to contract all over the surface of the tissue object, but you could tell it to just not contract anywhere except the belly if you wanted to do that. But really show those attachments. Cool. So when we made the fiber, we got the fiber node just like with attachments. And if we look at the attributes, we have two attributes that refer to strength. And this is a bit like stiffness in attachments, where you have the value and then the number of zeros after the value. Come down a bit further, we've got excitation, which is the one we're interested in for the moment. And so excitation takes a float value between 0 and 1, and 0 being not active or not excited at all, and 1 being fully excited. So this, you can connect to this attribute, and you can also keyframe it. So what I'll do is set a key on frame 30, and then say on frame 40, set it to 1. And I'm just going to offset the underlying alembic here, the driver alembic, so there won't be any animation on the bones for this example. And if I play this back now, you're going to see the muscle contract on around frame 30. So there you go. So the whole muscle kind of tightens up, and the shape of it changes obviously. And you also get, Ziva tells you that the fiber is active because the color changes as well. So for instance, and that's a useful debugging feature, so if we change the fiber strength to say 12 times 10 to the 1, it's not going to be strong enough to actually move the tissue, but you'll see that it is, it's fully activated, it's just not doing anything. So it's kind of a useful debugging feature. We can come in and set more keys here. Let me change that back. Right. So what we really want is to see the muscle contracting when it's primary function is supposed to be engaged. So for instance, with the bicep, you want to see it contracting when the elbow's bending, right? So I mean, we could go through and keyframe that, but in reality, you don't want to be doing that kind of stuff. You kind of want it to be automatic. So we have a built-in feature to do that. It's called line of action. And line of action is just going to contract your muscle based on a curve length. So I'll just delete the keys off here first. Then I'm going to shift my animation back so it's not offset anymore. And in the Ziva Tools menu, if you come down and select Create Line of Action Curve, you have to have a tissue with a fiber on it selected first. So you select that and then Create Line of Action Curve, and it makes this 2-point CV curve. There's nothing special about this curve. It's just a regular CV curve with 2 points. So you could make it however you like, really. I'm just going to move it a little bit along the radius because we want the curve length to change significantly when the arm's being bent. So I'm just going to move that out a bit. And now I'm just going to do some really basic Maya rigging and add clusters to either end. And then I'm just going to rivet clusters to the bones. Oops. Alright, so just want to check that it's following. It is, it's good. And now we need to connect this curve to the Z-fiber object on the muscle. So I'll select the curve first, then the tissue with the fiber on it, and then under the Ziva menu I'll come down to Add Tissue Property, and this time select Muscle Line of Action. And if you select the curve, you can see one of the outputs now is this Z line of action. So if we play back the simulation now, hopefully you'll see the fiber change, the muscle changes, the animation happens. So you can see as the arm bends that the color of the fiber is changing. It's not quite getting fully activated. It probably would if the elbow bent even further up. So if you want the line of action to be more sensitive to the curve length, you can go into the Z line of action node and change position sensitivity. To make it twice as sensitive, you change it to 2, for instance. I'm just going to change it to 4, just to make it super obvious. Clear this cache in the scene. And you can see now that it's getting fully activated quite often. So I could then go and I could use the same curve, for instance, to fire the brachialis as well. So we can just go ahead and do that now. Ziva, add fiber, muscle fiber, and then super quick, add muscle line of action. I'm going to change the second line of action to 4 as well. Let's clear that cache. So now you're going to see both fibers firing at the same time from the same line of action curve. So yeah, it's pretty quick to author all this stuff, and it's pretty powerful. It's all non-destructive. You can see all the nice jiggle effects are still in there, the sliding attachments, and you can see that when the muscle contracts as well, it becomes effectively more rigid. So, which is exactly what you would see in a real muscle. That is it for fibers for this video. As always, thanks very much for watching.